Hey y'all, welcome to Miss Clarke's chemistry class. Are you struggling with telling the difference between a physical change and a chemical change? Well, I'm here to show you all of my hacks. If you missed my video on physical properties, make sure and check that out first. A physical change is a change to a piece of matter that does not change its properties. Physical change, no new property. So, for example, we go out into the forest, we chop down a tree. The tree is changed, but the tree chemically didn't change. None of the atoms rearranged. We do not get a new material. Our material just looks different. Or if we take a piece of paper and just rip it up, we've got smaller pieces of paper, still paper. Let's say we're going to get gas and some of the gas spills out onto the ground and we look over and notice a few seconds later it's evaporated. That is a change, but it evaporated. Its particles are still the same. They're now vapor particles, not liquid particles. Any kind of state of matter change, always a physical change. Think about water. I think water is the best example because we're very familiar with it. We know about water in 3 states of matter: ice, liquid water, steam. All of those are composed H2O. None of them are a different compound. We have frozen H2O, liquid H2O, gaseous H2O, all H2O. So states of matter changes, if we talk about freezing, melting, condensating, all of those states of matter changes, always physical. You know, if I'm telling you the truth, that's where students get mixed up the most, because a lot of times questions can be worded to where it seems like something chemical is happening. We're going to get a new substance. But no, if it says those key words that clue us into a state of matter change, physical change. So let's look at a physical change. We have lead nitrate, and if we dissolve some of that lead nitrate into water, the lead nitrate retains its properties. It's going to dissolve. Dissolving is a physical change. The particles are getting much, much smaller as they dissolve in water, but the particles are retaining their properties. The same thing with potassium iodine. We can dissolve some potassium iodine in water. Oh, we got a little bit of a color change here. But that is just because iodine is in it. That's not a chemical change. This is still a physical change. We dissolved the potassium iodide into water. That means the potassium iodide particles got smaller, but they're still there and they still retained their original properties. Dissolving is a physical change. And then a chemical change, new physical properties arrive. A chemical change means there is a rearrangement of atoms and we get a brand new piece of material. So all of the old physical properties go away and we get new ones. That is a chemical change. Another name for chemical change, chemical reaction. Now I feel like we have all heard about what a chemical reaction is. We just didn't realize that a chemical change is a chemical reaction. You get brand new materials. If we take that piece of wood that we cut down in our forest, when we chopped it, physical change. But now let's make a campfire with it. And when we set it on fire and we get ashes left over, ashes, wood, not the same compound. New properties, chemical change. Or that gasoline that we spilled on the ground and it evaporated into the air. What about the gasoline we put in our car that makes our engine run? That's combustion reactions. That is a chemical change. When that exhaust comes out of your tailpipe, the compounds are different than the gasoline compounds because the atoms were rearranged. Chemical change. Now, how do we know a chemical change has occurred? We have 5 indicators here. Any one of those happens, chemical reactions happening. There is a change in temperature. That is evidence of a chemical change. We started at 30, we ended at 40. A change in color. If we mix 2 things together and then we get a brand new color and you can't undo it, that is evidence of a chemical change. If the odor changes, that is also an indicator of a chemical change. The formation of a precipitate. This example is going to take into account 2 of those indicators. These are the 2 mixtures that we created when we showed physical change. But if we mix these 2 together, chemical change. Yes, this was tinged a little bit yellow, But come on, y'all, that's pretty cool. Can you see the precipitate that's fallen to the bottom of the beaker? We mix two liquids together and we get a solid. Chemical change. The formation of bubbles. When we mix two materials together and all of a sudden gas forms, that's an evidence of a chemical change. Or if we produce light. When we change a piece of matter and light evolves, that is also evidence of a chemical change. All right, well, I hope now we feel super confident with identifying a physical change or a chemical change. You can do this, I know it. And if this video helped you, press the like button. Leave me a comment down below and tell me what your favorite part was. Don't forget to subscribe. Bye, y'all.